PIV, there's one final calculation, PIV, which is the voltage peak reverse voltage. What does that diode feel when it's reverse biased? How much voltage will it feel when it's reverse biased? So this diode is open. What is the voltage across that diode? That's what PIV means. And this is important when you size the diode, when you're designing one of these circuits. So that's V out peak. So that's V peak rectified plus 0.7. There's 2 or 3 ways of finding the PIV. This is one way of finding it. And I know what my V peak rectified is. It's 9.9. And I add 0.7 to that, and that gives me my PIV rating of the diode. How much? 10.6. So this is information that I use when I design the circuit and I want to size the diodes. Okay, so now let me show you where these equations are in the document. Yes? Yes, VDC average is by output. So this is output voltage at RL. I have all of these notes in a PowerPoint format on DC Connect, but some of it is shown in the appendix as well. So if you go to page 8 of the appendix, go to page 8. And this one page summarizes the equations and the graph and the values. Okay? So that's appendix 1. Appendix 2 is adding a capacitor, which we're going to talk about in a minute. But first, let's draw the graphs. Let's draw the graphs and label the graphs on page 2. Because on a test, in homework, in the labs, you need to draw these properly. So, the 2 graphs on page 2, the top graph is B secondary. B secondary. So the first thing I do when I show a graph is the 0 volt line. So 0 volts is right here in the middle. And the next thing I show is the peak value. So what is the peak value? Tell me. 11.3. That's all. Yeah, it's understood, but if you really want to, then I think it's a good idea to show the negative 11.3. Okay, the second graph below it is the graph of V out. And what's V out going to look like? It's going to be those pulses that we show. For the positive half, the pulse is like this. For the negative half, same pulse and same and same. You can use the dotted line as your guide and draw those pulses for the positive half and for the negative half of the B secondary. Again, we show the 0 first, and then we show the peak value. How much? 9.9? Yes, 9.9. And information. This is one cycle here. On the secondary side, what is my one cycle on the output side? It's half of that, isn't it? Actually, in terms of frequency, the frequency is doubled because the cycle is here. So this is for the input, the frequency on the output is doubled. Okay, so that's without the capacitor. Now, what we're going to do is for this circuit that I have, I'm going to add a capacitor. And if I put a big fat capacitor, okay, in the lab, that's what we're going to do. We're going to add a big capacitor. But if you're adventurous, and we've had a number of capacitors popping and melting and all kinds of things, okay? And you have to wear your safety glasses. We cannot emphasize enough that you have to wear your safety glasses, okay? Please wear safety glasses because one incident, okay, and we have to call the ambulance. Because what if that capacitor explodes and it hits you in the eye? Okay, so what if we put a big capacitor in my circuit? What I'm going to see is this. Watch. That's what I'm going to see. And some of you saw that with the 2-diode rectifier circuit that we built this week. And so what do you think will be out with the capacitor, with a big fat capacitor? How much will it be? Close to 9.9 volts.
Okay, bro. I just had a quick question about the Vout at 9.9. If you have a resistor load after the first diode, won't it be leaving one diode? So the Vout would be 10.6, not 9.9?
Nope. You have to do the full circuit when you analyze it. So you have to take both diodes into consideration. Okay, D1 and the other diode is your 1.4, and then the rest of the voltage is at the resistor. Yes. Okay, so with a big fat capacitor, my voltage will be 9.8, 9.85, somewhere around there. Okay, so let's do the calculation and see whether we get close to 9.9 volts. So page 3. In the circuit of example 1, let's add a 200 microfarad capacitor. And where do you show it? You connect it directly across the load. Okay, directly across the load. So this is the circuit that I want you to draw. On page 3, draw this circuit. Draw the diamond and show the diodes without my help, without looking at page 1. See if you can draw the diodes, the 4 diodes. See if you can remember how to point the diodes the correct way. AC, AC, DC, DC, plus, minus, AC to DC, AC to DC. You see, those are the first 2 diodes that I draw, from AC to DC. Now, instead of showing the load connected from plus to minus inside, I'm going to show it outside, which does not change the circuit at all. It's still the same circuit, but I'm going to show it from plus to minus outside. So here's plus, here's RL, and I'm connected to the minus. Because inside, it gets pretty crowded, so I can show it outside. It's still the same circuit. And now, I show that 200 microfarad capacitor right here. Across RL. And the plus of the capacitor will be at the top, where the plus of my DC voltage is. And the plus on the resistor is also where the plus of the DC voltage is. Everybody see that? So that's the circuit. Now let's do the calculations. The first three calculations are the same. It's only the VDC average calculation that is different. So let's first write down the first three calculations and say same. So V secondary RMS, same. How much? 8 volts. That doesn't change. Just because I put a capacitor in the circuit, the secondary voltage is still 8. V secondary peak doesn't change. How much?
11.3.
V peak rectifier doesn't change. It's only VDC average that I have to now use a formula that has the capacitor in it. So VDC average, not same. Now that I have a capacitor, I know, as we explained, that the voltage is going to be fairly a smooth line, okay? Also called a ripple voltage, because if I don't use a big fat capacitor, then I might see a voltage that looks like this. But if I use a big fat capacitor, then it's going to be like this. So, the equation is shown on page, by the way, let's go to page 10. Let's go to page 10. Page 10 shows 3 graphs. The graph at the top is the 4-diode rectifier circuit with no capacitor. Page 10. Everybody see that? The graph in the middle shows the same graph, but with a small filter capacitor. So you see a little bit of a ripple voltage. And then the bottom graph shows a large filter capacitor. And what does that graph now look like? Almost a straight line. So now let's go to page 9 and pick up the equation for VDC average. Equation number 3. V peak rectified times 1 over, times 1 minus 1 over. Okay, so let's write this equation on page 3. 1 minus 1 over 2 times the frequency out times R times C.
What is R?
R is my 1K,
No, I know, but ohm value.
1 kilo ohms.
Oh, okay, sorry.
It's the same as the circuit of page 1. I just added a 200 microfarad capacitor. Okay, so V peak rectified is 9.9 times 1 minus 1 over 2 times frequency out. Frequency out, there's a note at the bottom of page 9 that says frequency out is 2 times frequency in, because this is a full wave circuit. So what is my frequency in? 60 hertz. So I go 2 times 60, which is 120. R is 1K, so I will write 1K as 1E3. 1000 ohms. C is 200 microfarads. I will write that as 200. What is micro?
10 to the negative 6.
Negative 6. So I'll write that as E minus 6. And I do this calculation, and what do I get?
9.7.
9.7. If you get 10 or 11 or 12, it's time to pause and say, maybe I made a mistake in my calculator. Can it be more than 9.9? No. So that's what you have to remember. So 9.7. It can never be more than 9.9. So now, let's draw this graph on page 4. Top graph, B secondary. 0 in the middle. Peak value, how much?
Ripple peak?
No, this is B secondary.
11.3.
11.3. I'm on page 4. Page 4, top graph. Bottom graph, B out. So, I'm going to use the dotted line guides, and I'm going to draw a graph that I'm going to exaggerate it a little bit. So I'm going to draw the graph like this. That's what I will see on the scope. Actually, it won't be that much of a ripple. It'll be much smaller than that. Nope. This is 0. Thank you for pointing that out. This is 0. So use the dotted line is where your graph is. And I'm going to show the dotted line is the peak. So what is that value? Same as before, 9.9. So where do I show my 9.7, do you think? Nope, not where it ends. It's in between 9 and 0.9 and the bottom. So it's about halfway. So it's right in here. Because it's the average. So this is 9.7. You follow? So if it was a flat line, then it would be 9.9. But because it's 9.7, it's right. It's just below 9.9, and where the bottom is. Okay? So it's halfway between the upper part of my ripple and the lower part of the ripple. It's halfway in between there. So where do you think is the bottom peak, bottom point of the ripple? What is that voltage, do you think? If this is 9.9, and if halfway is 9.7, how much do you think is here? 9.5. Because it's between 9.5 and 9.9, which is 9.7. Everybody see that? There is a formula to actually calculate the size of the ripple voltage. So let me take you to page 8 for that. No, page 9. Go to page 9. Look at equation number 4. Page 9 equation 4 says V ripple peak to peak. So what is that voltage? It's this voltage here, isn't it? That's my peak to peak of the ripple, isn't it? If I use that equation there, I will get a value of about 0.3, 0.4, depending on the size of the capacitor. The bigger the capacitor, okay, the bigger the capacitor, is the ripple going to be big or small? Small. So the ripple becomes small. That peak-to-peak ripple becomes small, 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 until the voltage will be just skimming the surface of the peaks. Make sense? So this is, so the same concepts, we did it 3 times. 1 diode, 2 diodes, 4 diodes. The 4-diode rectifier circuit is the most popular. You do 4 diodes and you get full wave, you put a capacitor, you get a straight line. You convert from AC to DC. So we started out with 120 AC, we got 6.3 no cap, and 9.7 with cap. And this is smooth. Everybody see that? With the capacitor, the voltage increased to 9 volts, 9.7 volts, and it's smooth. This is what they do with 99% of all power supplies in the world. You want to convert from AC to DC to operate your cell phones, to operate your laptops, to operate everything that needs DC, you use a bridge rectifier. So before you go, let me give you back your homework assignment. So I've got Rebecca,
I'm curious to see the outcome.
Holly, Gibson,
I know what you're thinking about.
Christian, Hazel,
You've been doing it all day.
Stephanie and Heather, Trudon. Listen, I encourage all of you to work in groups of 2, okay, with homework. It's a good idea. Albert, White Coco, Albert Cho, Dylan, Gary Knock, Anand, Harsimran Kaur, Eric Rempel. Don't go away. Daniel Fry, Harrison Rosemont, Pratik Singh, Mandar, Kirk, Sarah and Mahila, no, Sahil, Mahila. Boston,
No, I didn't change the shift.
Delahaye, Hunter O'Neill, Hunter, Bradley Barron, Bradley, Harris Corey Palmer,
How much or little or big or small or
Sarah, Justin Bascom, Justin, Salim, Rob Jones, Jacob Hardy, Jacob Grant Howard, Gary Knox, that's it. Have a good weekend.
I got 1.5 because I didn't write the number and I thought
I'll be okay with that.
so it was like 2 amps. I was like, alright, in class. It's actually 9 volts 20 amps. I'm like, wow, that's cool. That's cool.
What? Give me a second. I'll try it. Excuse me.
You just wrote 2 questions. I know that's going to be.
Quick question. We're only going to take 2 seconds.
Oh my god, you got a point
I'm
five?
giving you all the cheating,
Don't really do it.
like last year it was open book.
I lost 0.3.
On what?
Yes. I know that. But I would have just kept it.
Just for time's sake.
Is Harrison coming too, or did he just leave?
Yeah.
Yeah.
Harrison's got classes.
Do you know before or something like that? By the way, did you relapse or anything? That's what I'm saying for.
Shit, man.
Did you finish it all? Yeah.
Did you go online and get the revised version? Yeah, where it had like the 9 volts and stuff like that.
No. You could use 20 milliamps.
Yeah, it's been on there. He uploaded it when he gave us
I
some.
had on the,
He told us to use that one instead. We had the changes.
I said, that one that I had.
Like, because then you would have had the 9 volts. One before. Would you even have?
Yeah.
Hot dog.
Yeah.
Oh no.
If you're calculating this, you would only apply one. But all of the is getting clear. Same that's why. Let's go, so one is allowed. Alright, take care. I'm good, we got. Yeah, you too, guys.
Because I said in class to change the 5 to 9.
So I forget what I was asking for, but you were following what I was doing, right? I think so, yeah. Whatever one factors in the voltage drop, you dial.
Yes, I know. I wrote down on the board, to change the 5 to 9. a question now?
Yeah, I was actually talking to another.
Oh, it's a camera. Yeah. Next thing you know, that's gonna like play in some weird places. It's recording. Really? Yeah. What is this? Yeah. Why did it take the video down? It's so beautiful. Okay, this is not the video, but why? It's so random. Eat arm spaghetti or bomb spaghetti? Eat arm spaghetti. No. It was it's not an actual song, but when someone said, "Oh, I mean, says a word in the song, it sounds like spaghetti. Let's make it the whole song." Whose camera is this? I'm so attracted to it.
You just have to go.
I just and it's recording too. It's just hearing it. Can't film the comments. I know. Whose camera is this?